All right, what's going on, y'all? This is Sean, owner and lead tutor of Math Swap Tutoring, and today I want to talk about finding the derivative of inverse trig functions. All right, cool. Well, good stuff. Before we get started, of course, as always, look at the bottom of the screen if you were interested, or you can look in the description too. But if you're interested in tutoring, math tutoring, then you can use that link to schedule a free consultation. Also, if you're, sophomore, junior, senior in high school, and you're looking to get your math score up on the SAT, even the PSAT, and ACT, then join our weekly SAT, ACT math practice class. It's a virtual group class, where we just kind of come together and we practice problems. You get an SAT book, you get an ACT book. We run through problems. You get the opportunity to ask any questions that you have, and it's fun, and it's really good practice. So make sure you use that link, patreon.com/mathswap tutoring. Sign up there. And don't forget to subscribe to this YouTube channel and to like and share this video. All right, now, so when it comes to finding the derivative of inverse trig functions, so you need to know the derivative of sine, inverse sine, inverse cosine, inverse tangent, inverse cosecant, inverse secant, and then inverse cotangent. So I have all of these in my notes, but I'm not going to put them all here because they'll take too long. But if you go and subscribe at Math Swap Tutoring, .com/subscribe, you will get a link to the downloadable math notes that I make for these videos. Scroll down to calculus and you will see the notes that will include the actual derivatives of these. So I'm assuming that you have those available for you when you watch this video. But yes, so that's the first thing you need to know. And I always encourage people, whenever you're finding finding derivatives that are associated with these inverse trig functions or any of these other ones, you want to try to commit them to memory, but still have them open in front of you, okay? Because it's kind of hard to remember the derivatives off the top of all of these things. All right, so here we go. So let's given that we know what these right here are, we have them open in front of us, the separate derivatives of each of these inverse trig functions. Let's now start finding some derivatives. So let's find the derivative with respect to x of 4 tangent inverse x cubed. Now, remember as well, even as you find derivatives using that have inverse trig functions involved, you will still need to remember the chain rule, the product rule, the quotient rule. All those type of things will kind of apply, as you'll see. So look at this, the derivative of 4 tangent inverse of x cubed. Now, so we have 4 tangent inverse. If it was just 4 tangent inverse of x, then we could just do, it would just be 4 times the tangent inverse of x, whatever that derivative is. But because the argument of the tangent inverse is x cubed, we're going to need to use the chain rule, which is going to be the derivative of the outside, which is 4 tangent inverse, and then times the derivative of the inside, which is that x cubed part. Now, you might want to watch my video on chain rule to kind of get refreshed on that. I'm just going to assume that you already know that, or that you watched that video here. So let's do 4 tangent inverse. Okay, so the derivative of the outside piece. So that's going to be the derivative of 4 tangent inverse of x cubed. So that's going to be, so the derivative of tangent inverse is as follows. Hold on a second. Let me make sure I have my own notes open here. So the derivative of tangent inverse, I just write that here, is equal to 1 over 1 plus x squared. So the derivative of 4 tangent inverse of x cubed is going to be, of course, now instead of 1, we're going to have that 4 there. Because the 4, the constant is going to stay with that. 4 over 1 plus, now notice this, the derivative of tangent inverse of x is equal to this when your argument is x. Whatever that x argument is squared here. In this case, the derivative is going to be not x squared, but it's going to be x cubed quantity squared. You see? Because the argument now is not x, it's x cubed. So it's whatever the argument is squared is the key. So the argument in this case is cubed, x cubed, and it's going to be squared. All right, so that's the derivative of the outside piece times the derivative of the inside piece, which is the inside is x cubed. So the derivative of 3x cubed is going to, I'm sorry, the derivative of x cubed is going to be 3x squared. Now let's combine these and simplify it. So 4 times 3x squared up top is going to be 12x squared up top. And then down here you have 1 plus, now x cubed to the second power, you multiply those exponents. So that's going to be x to the 6th for your final answer here. Okay. All right. So you see that we had to know the inverse, the derivative of inverse tangent. And we had to apply that here. And we also had to apply the chain rule. Okay. All right. So let's go on to another example here. I'll leave that up. All right. So let's do the derivative. Let me go back on my notes here. Okay. Yeah, here we go. All right. So the derivative of sine inverse times cosine inverse. All right. So let's write separately here. The derivative of sine inverse, okay, is equal to 1 over the square root of 1 minus x squared. The derivative of cosine inverse is going to be equal to negative 1 over 1 minus x squared. I mean, the square root of 1 minus x squared, sorry. Make sure I'm saying that right. So to apply that to this particular problem, remember, this is 2 functions being multiplied times each other. So we're going to use the product rule, which is the first times the derivative of the second plus the second times the derivative of the first. So that's going to be the first function times the derivative of the second, which is negative 1 over 1 minus x squared, plus the second function times the derivative of the first function, 1 over 1 minus the square root of 1 minus x squared. Got to be careful, keep all that stuff in there. All right, so let's kind of combine this stuff together. So this is going to be negative sine inverse of x over 1 minus x squared plus cosine inverse of x over 1 minus x squared. Now, if you notice, these are being added together and they have common denominators, so we can combine that even more. So that's going to be cosine inverse of x minus sine of x, sine inverse of x. I just reversed the order. You don't have to, but since it's being subtracted, I'd rather kind of have that on the right side rather than the left. So that's going to be over 1 minus x squared, square root. Okay. All right, again, not that bad, pretty straightforward. But this is application of the derivative of different inverse trig functions, as well as application of the product rule. All right, so let's do one more example and then we'll let that be it for this video. And as you see, this stuff really isn't that bad. As long as you know the derivatives, which you should have open in front of you or committed to memory, it's gravy after that, okay? All right, so finally, let's do this last example that I wanted to do here. Remember, these are in my downloadable math notes if you subscribe to MathSwap Tutoring's email list. So the derivative with respect to x of 3 cotangent inverse of 4x. All right, so once again, you see that we are going to apply here the chain rule, derivative of the outside times the derivative of the inside, okay? All right, now, so let's do the derivative of the outside. Remember that constant is gonna stay there because if you were to do, you could also look at this as being like the product rule. The first, which is 3 times the derivative of all this stuff, plus the second times the derivative of all this stuff. But when you do that, plus the second times the derivative of the first, you know the derivative of a constant is 0. And so that would all go away. So that's why you already know that if it's just a constant in front, just carry that constant over. All right, so that's going to be, well, let me go ahead and make sure I have the, derivative of cotangent. Let's write that first. -1 over 1 plus x squared. All right, so the derivative of the outside is, I smile because I keep on kind of slurring my speech whenever I say the derivative. So I just need to slow down. So the derivative of the outside function, which is going to be 3 cotangent inverse. So that's going to be essentially 3 times this. So it's going to be -3 over 1 plus x squared. Oh, and I almost messed up, but remember, the derivative of cotangent inverse of x is -1 over 1 plus x squared. So this, whatever the argument of the inverse trig function is squared down here. So the same thing here. The argument of this inverse trig function is going to be squared down here, okay? All right, so that's the derivative of the outside times the derivative of the inside. The derivative of 4x is just 4. So that's going to give us -12 over 1 plus 4x quantity squared is 16x squared, okay? All right, and you were done. Hopefully you see it's not that bad at all. It's just okay, good. It's not bad at all. You know, you're using some, algebra there and just kind of like whatever you know now of what the derivative of different functions is. Just be careful with your signs, be careful with your exponents and all that type of stuff, and you shouldn't have any sort of issue. Make sure you subscribe, like this video, share this video, follow me, all that type of stuff, because I will continue to post. And enjoy calculus.